Welcome back to a new machine learning tutorial. In this video, we are going to talk about AdaBoost classifier. We are going to talk about the logic behind the algorithm. We are going to code it using Python, and then we are going to do hyperparameter tuning and talk about its parameters. Let's start coding. Okay, I'm in Visual Studio Code and I prefer this code editor. You can use any code editor that you want. I'm going to create something like AdaBoost classifier, and it's going to be a Jupyter notebook. I will say IPMB. Next up, I'm going to select my kernel 3.11.4 and I will type adaptive boosting. And let's talk about it. So, this is an ensemble learning algorithm that combines the outputs of several weak classifiers to form a strong classifier. So we are going to be using weak classifiers for having a strong classifier in adaptive boosting. It works by iteratively improving the model, focusing more on the data points that were misclassified in previous rounds. The idea is to adaptively adjust the weights of weak learners so that they collectively perform better on difficult cases. And step by step, we can type weak learners for the first step, and in here, weak learners used by AdaBoost are usually decision stumps, which means decision trees with a single split. These weak learners perform just slightly better than random guessing. And next we will have boosting process, and in each round the algorithm assigns higher weights to the samples that were misclassified by the previous model. Trains a weak learner based on the updated weights, combines the weak learners to create a strong final model, assigning higher importance to learners that perform better. And the next step is going to be the weight updates. And in here, after each weak learner is trained, we update the weights of misclassified points, making the next learner focus more on these difficult to classify examples. And at the final model side, we are going to have the final prediction is a weighted vote from all the weak learners, where are the weights determined by how well each learner performed. And this is the logic behind the adaptive boosting. And let's start coding. So I'm going to start by the imports. We will say Scikit-learn.datasets, import make classification. I will say from Scikit-learn.ensemble, import AdaBoost classifier. I will say from Scikit-learn model selection, import train test split. From Scikit-learn.matrix, import accuracy score. Next up, I am going to say import warnings, and I will call warnings, filter warnings, ignore, because I don't want to see any type of future warnings or depreciation warnings since they are useful for this tutorial. Next, I'm going to create my data using x and y. Make classification function, we have in here number of samples, let's say 1000 for this, and number of features, let's say 20 like this, and we can use 12 in number of informative. I'm going to say 12. And I want a binary classification problem like this. So I'm going to make it run, and at the x side we are going to have a matrix like this with the shape of 1000 to 20. This is our matrix, and at the y side we are going to have a vector, a binary classification problem which has zeros and ones, and it's the shape of the y we have. Okay, so in the next step we are going to apply train test split. So, in the steps like train test split or model evaluation on accuracy score, I have tutorials on all of these topics in my machine learning tutorials playlist on the YouTube channel I have. There is like 40 videos just like this one. You can check that playlist from the description of this video or from the cards of this video. And I will say x train, x test, y train, and y test. I'm going to say train test split. I will pass x, y with the test size of 0.2. So now we have 80% of the data in the training set, x train and y train, 20% on the testing set, x test and y test. Great. Now we can initialize the base model. I will say base model. Next up, I'm going to call AdaBoost classifier. I'm going to initialize it like this. And in here, we are not going to do something like parameter tuning. In the next step, we are going to do that. I will say base model.fit x train and y train. And now we have our model ready. Now we can use it for predictions, like I'm going to predict the x test and we are going to have values like this. I'm going to store them into something like y predictions, and I'm going to call accuracy score on true y values with y predictions, and our value is going to be 0.78. Now we are going to talk about parameter tuning, which is the process where we optimize the model's parameters for better performance. And accuracy score can take values between 0 and 1, and values closer to 1 is better, so we are going to try this accuracy score with our parameter tuning. So let's talk about the parameters of the adaptive boosting. We are going to have a number of estimators, and this is the number of weak learners to train. More learners generally improve performance, but also increase computation time. And we are going to have learning rate, and this controls the contribution of each weak learner to the final model. Lower values slow down the learning process, but may lead to better generalization. And we are going to have Bayes estimator. By default, AdaBoost uses decision stumps, but we can specify any other weak learner, like a small decision tree, as the Bayes estimator. So let's do hyperparameter tuning. I will say from Scikit-learn .model selection import grid search cross-validation, and I will say from Scikit-learn.tree import decision tree classifier. So decision tree classifier is going to be useful on the Bayes estimator side. I'm going to define the parameter grid for the tuning. Parameter grid is going to be equal to the number of estimators is going to be 50, 100, 200. You can extend this list. I want it to run fast, so I'm not going to do that. Learning rate, we are going to have 0.01, 0.1 and 1. And as the Bayes estimator, I'm going to give like decision tree classifier with the max depth of 1, and next I'm going to give decision tree classifier with the max depth of 2. So it's going to be our grid, and I'm going to set the grid search like grid search cross validation AdaBoost classifier, and I'm going to say parameter grid. Actually, I need to add parentheses to this. Parameter grid cross validation is going to be 5, and scoring is going to be accuracy. Next up, I'm going to fit this grid search.fit xtrain and ytrain, and when this finishes, I will be re-recording. It's finished in 20 seconds, and we can get the best parameters using grid search. Best parameters, and 200 for the number of estimators, 1 for the learning rate, and max step 2 decision tree classifier for the Bayes estimate. Again, you can extend these lists. And now what I'm going to do is I will say grid search best estimator .predict, and I'm going to call this on X test. We make predictions. I'm going to store them in something like y prediction tuned, and I'm going to call accuracy score with our tuned models results with y test. So our new accuracy score is 0.89. So let me check the last value. It was 0.78, and we improved our model's prediction performance by hyperparameter tuning. Okay, let's summarize what we did in this video. We started about talking on adaptive boosting and how this process works. We use weak classifiers for a strong classifier. Then we created our data. I showed you the data metrics on X and vector on Y. We used train test split. I mentioned machine learning tutorials playlist. You can check that for more tutorials like this. I initialized the Bayes model like this, and we trained our model using the training set we have, and we make predictions on the X test with comparing Y test with accuracy score, and our accuracy score is 0.78. Next, we talked about the hyperparameter tuning and the parameters that we can pass in AdaBoost, and we define the parameter grid in here. We set our grid search and train it. Next, we check the best parameters and decision tree classifier with max step 2, learning rate 1, number of estimators 200. Again, you can extend these lists, like you can say 500 in here and try them out. And we make predictions with these parameters, and we get the accuracy score of 0.89. That was it for the coding part of this video. Let's get to the outro. Thanks for watching this tutorial on AdaBoost Classifier. I have a machine learning tutorials playlist where I have more than 40 videos just like this one, You can reach that playlist from the cards of this video or from the link in the description. Also, I'm sharing a new data science video every week. You can subscribe to my channel for more videos like this. Have a great day.